Hello and welcome to this video where we're going to use trig to find side lengths of triangles. So first things first, I have to start off by saying that this is only going to work, or this method only works when we have a right triangle. So if we don't have that, we have to have that. If we don't have it, we can't use this method. Next, let's take a look at a trig function. So sine of theta is equal to opposite over hypotenuse. What I'm seeing here are three pieces. And what's going to happen is we're going to swap out theta for some actual number. So we might be like, this is 25 degrees. And then we're going to put a number here and then essentially put a variable there. Okay? And that's what we're going to have to do is now use this information to find the side length of a triangle. So let me cook up a real example here and let's take a look at it from there. So let's go with the dark blue. And let's say we have a triangle that looks something like this. We have 35-degree angle right there, and we're told our hypotenuse is 7. And what we're going to do is we're going to mix this up. We're going to be doing x and y. Okay, so first, let's focus on x. If we want to focus on x, or solve for x, what I care about is this angle, the x, and the 7. And I got to ask myself, what do I have here? Well, what I see is opposite and hypotenuse. And so if I'm dealing with opposite and hypotenuse, I want sine. Now what I'm going to do is I'm going to swap out theta for 35. So I'm going to put sine 35 degrees is equal to my opposite side, which is x, over 7. Now this might look weird. We've got to remember that this thing right here is just a number. All right? That's why I have a calculator. So we're going to type that in a second and figure it out. But if I want to figure out what x is, I need to get it by itself. So I'm going to multiply both sides by 7. And so x is going to equal 7 sine theta, or not sine theta, sine 35. And then that's my answer. So 7 sine 35. There we go. X is equal to 4.02, give or take. Now, I want to point out a couple of things. One, we got to be careful. We can't go sine 35 times 7 like that. You got to make sure that you have parentheses around the 35 because that is where, that's all we're taking sine of, is 35, not 35 times 7. Another thing you should be you should show some caution towards is, let's say you do sine 35 in a calculator and you let it be 0.57. Now, sometimes it's not going to have that much of an impact, but if we take 0.57 and we times that by 7, you can see 3.99 is not the same as 4.02. So the point is you want to try not to round early. If this were to arise, let's say you crunch the numbers and you get sine of 35, what you should then do is take your answer and times that by 7. All right, so yeah, use that answer key on a button. All right, now let's say we want to find y. How would we do that? Well, again, I'm going to look at my trig function or my triangle through this perspective, and I see adjacent and hypotenuse. And if I have adjacent and hypotenuse, what that means is that I'm probably going to want to use cosine. So I'll go with cosine of 35 is equal to y over 7. And as you can see, I'm going to have to multiply both sides by 7, so 7 cosine of 35 will equal y. And so go back to my calculator, make that happen, 7 cosine 35, and I have y equals 5.73. And so this is how we're going to use trig functions to help us identify missing sides in right triangles. Now, these are two pretty basic examples. Let me draw a new triangle and show you something a little more difficult. All right, so let's see here. Let's go with, I think we should go with purple. What do you guys think? All right, and this time let me draw my triangle so that it goes like that. All right, 6, 27, and then we want x and we want y. All right, so what I'm going to do is really quickly, I'm going to take care of y first. I think y is going to be an easier one. Now, again, I want to look at 27 and I want to see what I have. I have y and I have 6. I always need to use that number there. So if I have on my triangle my opposite side and my adjacent side. So to me, opposite and adjacent, that means we need to do tangent of 27 is equal to y over 6. And then y is just going to equal 6 times tangent of 27. So again, notice how I'm typing it and how I'm writing it. I'm trying to put my 6 first instead of last, and then go tangent 27, and then here y equals 3.06. There we go, give or take, about 3.06. All right, now y was kind of easy. I wanted to show you that tangent is fair game for use. But now let's take a look at solving for x. This one's going to be a little more complicated. Now what I'm seeing is adjacent and hypotenuse. So I'm going to use cosine. So cosine of 27. And then what makes it tricky is now it's 6 over x. So my variable is down in the denominator. So to deal with that, I'm going to multiply both sides by x first. So I have x times cosine of 27 is equal to 6. And this looks weird, but I got to remember that cosine 27 is just a number. And so, if I had x times 3 is equal to 6, I would divide both sides by 3 to get x by itself. I'm going to do the same thing here, except it's now going to be the cosine of 27 that I'm going to divide by. So cosine 27, and then x equals, let's type that in, so 6 divided by cosine 27, we get 6.73, give or take. And there we go. This is how we use trig to find missing side lengths of right triangles. Again, it has to be for a right triangle. Second, what we want to do is zoom in on whatever angle we have and the pieces of information we have. We really got to make sure that we focus on the number that's given to us because we need that. We have 3 pieces in our trig function, or our trig equation here, and we need to be able to put in 2 of those pieces to find the third. So good luck on your homework or practice, and let me know if you have any questions.